Question 5, a cup of hot chocolate is freshly made. Its temperature in degrees Fahrenheit can be modeled by this function. So T of T equals 190 e to the power of negative 0.7 T plus 72. T is the time in minutes. And we have some questions here. So what is the temperature of the cup of hot chocolate immediately after the cooking process is completed? What's the temperature after 4 minutes? And then how long will it take to reach 88 degrees? Okay, so we want to find, right here, we're actually get to plug in values, which is nice. Because here is our function. And the first two questions are saying, well, what happens when T is a certain value? So here, what's the temperature 4 minutes? So when T equals 4, and this is saying immediately after the cooking process. So what do you think T should equal here? T would equal 0. No time has passed. It's right when it's done, and then we start the time since the cooking was completed. So our first one, we're going to put T equals 0, and I'm just going to copy the thing. 190 e to the power of negative 0.7. T is 0 plus 72. So 262 degrees. Dang. And then it's cooling off. That's why we have a negative up here. So after 4 seconds, it's down all the way down to 83.6, rounded to the nearest tenth. So in just 4 minutes, that's cleared a lot. So it's saying, how long will it take for the cup of hot chocolate to reach 88? So now we're solving for T. Solve for T. And the temperature, this part, is going to equal 88. So I'm going to rewrite it like that. 88 equals 190 e negative 0.7 T plus 72. And we know how to solve these. We've done it before, so we're trying to find T, and we need to isolate the exponential part. So 88 minus 72 is 16. And then we're going to divide by 190, and that's going to get the e by itself. So 16 divided by 190, let's see if I can reduce that. 8/95, I'm going to leave it as a fraction until the very end. That way we don't lose anything with rounding. Okay, what do we do to get rid of an e and solve for a variable? We use a logarithm, but we use natural log. So I have ln 8/95 equals ln natural log. And that helps us bring down the exponent. That's the whole reason we have logarithms. So natural log of e is 1. I'm not going to rewrite it. Last step to get t by itself, you divide by that negative 0.7 and put this in the calculator, and that's t. And we're rounding to the nearest tenth. So I'm just going to delete this. I have natural log of 8/95 divided by negative 0.7. So 3.5 minutes to get down to 88 degrees.